Okay, this is lesson 6.2. We're going to talk about hyperbolas in this lesson. And the mathematical definition for a hyperbola is the set of all points in a plane. The difference of those distances from two fixed points is constant. The two fixed points are called the foci of the hyperbola. So hyperbola looks like this. They have, it's two kind of parabola looking like things that go off in opposite directions. So this is a horizontal. This one opens up left and right, has a the focus points are, the center here is at the origin, of course, and the midpoint of the line segment is called this between the two focal points is called the center of the parabola. So this origin is the center of this parabola. The vertices, where it crosses the x-axis in this case, are going to be called the vertices of the hyperbola. So it goes from, the distance from that is this a value. It goes from the center to here is a, to the center this way is a, and c on this one goes from the center over to left and right is bigger than a, right? It goes past a out to the focal point on this hyperbola. Okay. Okay, so the two equations, the two basic equations for hyperbola, this is one that opens up left and right. The other one down here opens up and down. This has the transverse horizontally. This has the transverse axis up and down. So the transverse axis is the axis where the focal points are at. And this is the focal points are at C here. So this goes a horizontal transverse. This is a vertical transverse. The equations are, only difference between them is the x and the y are reversed on these subtractions. Remember, this is a subtraction as opposed to an addition, which we had in the other equations for ellipses. Okay, so it's a subtraction, and a is the distance from the center to the vertices. C is the distance from the center to the focus point, and b is this other distance. It's called the distance of the minor axis. It goes from the center up to some point here, and it kind of gives us helps us give us the slope of these asymptotes, so we can help draw the parabola. And this one has, the difference between these is x squared opens up left and right, y squared first opens up and down. Okay, so we have problems like this where it says sketch the asymptotes and graph the hyperbola. Okay, so we want to sketch that. So we need to figure out where it's centered at the origin, right? Because we know that because the x's and the y squareds are that. So which way is it going to open up? Left, right, up, down? Well, we know it's going to open up left and right because the x squared is first. Okay, and we know that this, if x squared is opens up left and right, that a value, the way our book does it, is underneath the x. So a squared is 25, so that means a equals 5. B squared is underneath the y value, so that means that b squared equals 49 or b equals 7. Now this little equation here gives us the slope of the asymptotes that we use to help us draw the hyperbola. Okay, so it's just b over a plus or minus, there's two lines, a positive slope of 7/5 and a negative slope of 7/5. These are just linear equations there based on the values of a and b. Okay, so we have to draw this fundamental rectangle to help us draw the hyperbola. Okay, so I need to draw these 4 points right here first. Okay, so I'll go over to my graph. There we go. Okay, so I graph this point here is -5, -7. I want to graph this point too because this is one of my vertice points. That's, I know it's going to be on that axis. And I put this point up here too. And I go over and do the same thing over here on this side. And I'll put this point here too. That's going to be a vertice of my hyperbola. That's going to be the other where I draw my lines. Now I can draw them on here. You'll have to draw them by hand to when you do the graph. So I'm going to put this on the graph. Oops, I got too much. Put this on the graph. Okay, so that line goes through there. That's one line for the asymptote going one way. It's the line going for the going the other way. So I have my two asymptotes on here. So how are we going to draw the graph? So it looks kind of like when we draw it, I make the graph a little, bring it out a little bit, so I have a little more things to draw on there. And it looks like this. My asymptotes is going to open up left and right. It's going to go through this 5, 0. So my hyperbolas are going to be drawn like this along the lines of these asymptotes coming through here, something like that. Okay, so that's how you would draw the graph, the sketchy graph, and the asymptotes of the hyperbola. So you have to get these 4 points here. You have to get those just to graph the asymptotes, right? So sketch the asymptotes and graph the hyperbola. And you have to do that to graph the hyperbola. I kind of made a little boo-boo there, but you have to do that. Otherwise, you can't really graph it very well. Okay, so graph this one. This one is, it's a little different than the other one, not much harder. Okay, so what's the main difference? The main difference is that we have it off-centered, right? It's up at 2 and 3. So it's centered at -3 and -2. We can know that because of those offsets there. But it's going to look the same as the graph of y squared over 9, x squared over 4. Okay, so that means that our a value is going to equal 3 and our b is going to equal 2 because 9 is b squared and 4 is 2 squared. Okay, so what does that, how are we going to put the asymptotes on there? What are we going to do for that? Okay, so we get the equations for the asymptotes are the b squared over a squared, right? I should have put that, is 2 over 3. And because of our offsets here, we're offsetting that. It's going to be centered at, we're going to move it over 3, right? So I put a +3 there, and then we'll move it up, down 2. So that's where I get the -2 here. My 2/3 and my -2/3 graphs. Okay, so where are the vertices going to be on this one? So it's going to be, this one's going to look like, if I put these asymptotes on the graph, looks like that. This one. That's not what I wanted to do. Okay. That's what I wanted to do. Okay, so I get it. This is where the center of the graph is, right here on the, right here in the middle of the graph. That's my center of my graph. That's my center, the -3, -2. That's where the asymptotes cross. Okay, so where are my vertices going to be on this one? If I want to graph this one, I have to put my vertices on there. So where are they going to be on this one? So is this graph going to open up, down, left, or right? Well, I know my a value is 3, right? I know it's actually this, because this is a equals 3, b equals 2. Okay, so I need to go up. Let me make this, if I can make this a little, I want to go the other way. There we go. Okay, so I want to make this one, I want to go up 3. I know it opens up and down, so I want to go up 3, so I go up 1, 2, 3. That's, I go up 3. Yeah, I went up from -2 to +1. Okay, that's where my vertice is going to be. I'm going to go down 3, have to just do a little more here. Going the right way. Down 3, I want to go here at -3, -5. Right, I went down 3. So that's going to be the vertices of my parabola. So that's going to be where it's going to go through. Go out a little bit, get a little more perspective on this graph here. Okay, so to graph it, I'd graph it like this. It would come down along those asymptotes, through there, off like that. This is the bottom side. We do the same like that. Okay, so you have to get to your asymptote. You have to know which way you're going here. So I went up and down 3 from vertically from this center to get my vertices. I had my lines, my asymptotes cross over. I moved them from +2 minus, this was the slope, and I moved them over so that they were offset by the 3 and the -3 and the -2. Drew them on there, went down, up and down 2 and 3, went up and down 3, down, up 3, down 3 to get the vertices, and then I graphed it. Okay, so the last one we have to do here is write the equation below in the standard form of hyperbola centered at h and k. Identify the center and the vertices. Okay, so we have to get it to look like this form of the equation, right? We have to get it to look like the x. I don't want it to write like that. I want it to get it to be the x minus h squared over, and this one we know it's going to open up and down because x is minus y minus the y minus k squared over b squared equals 1. Okay, so I want it to get to look like that. All right, so what do I do with this equation? Well, we have to, the technique we've been using so far is to complete the square stuff. So we're going to do that same kind of thing here. So the x's and the y's are pretty well separated here. So I'm going to just take and rewrite this as 9 times x squared minus 2x plus something. And then I'm going to minus, and I think I can take a 4 out of there, minus 4 times y squared minus plus 4y, right? Because I have that's plus 4y plus something equals 43. Okay, so I just rewrote these with the 9 and the 4 taken out of there so I can complete the square easier. Okay, so to complete the square on the x's, half of 2 is 1. So I'm just going to add 1 there, right? Half of 4 is 2. 2 squared is 4. Excuse me. So what do I need to do? On this one, what do I need to add? I added more than 1, right? I added the 9 plus the 1. So I add 9. And this one is the -4 times that. So I subtracted 16. So what did I really do here? I actually makes it go +3 minus 16. Okay, so on this side, it's going to equal 36 when I do all that. And what did I accomplish on this side? Well, I got this. I got 9 times x squared, x minus 1 squared, minus 4 times y plus 2 squared equals 36. Now on our hyperbolas, we want it to have it be equal to 1. So I'm going to divide everything by 36. Okay, so that's going to give me 1 on that side. And when I divide 9 by 36 and 4 by 36, I'm going to get an equation that looks like this. 9 divided by 36 is x minus 1 squared over 4 minus y plus 2 squared over 9 equals 1. Okay, so that's my standard form of the equation. Now I can answer the first question, identify the center. Okay, so the center is going to be where? Well, it's going to be at x equals 1 and negative 2. So the center's at x equals 1 and y is negative 2. Okay, so it's a little easy. I wrote it here on this one. It looks a little better. So I got the center. That's the equation, how it looks, all nice and typed up. And we have to go back to our definition of here. What did they want us to find here? They want us to find the vertices, right? So the vertices on a horizontal axis are a value away from the center. So our center is, I'll write it again, the center is at where? It's at 1, x equals 1, negative 2. Our a value is 2, right? Because this is a squared and this is b squared. Okay, so I'm not having to draw this one this time. I just have to tell you where the vertices are. And I could tell you where the focal points are too if I wanted to. Okay, so to do that, we would go left or right. Which way are we going to go? So the center, we would go from our center point. We'll say that's our center at 1, negative 2. Our vertices are going to be where? We're going to add 2 to that going left and right. So add 2 to our x, and one vertice is going to be over here at 3, negative 2 is one vertice. I'm going to subtract 2, and the other vertice is going to be at negative 1 and negative 2 when I go 2 this way. Right? I went 2, subtracted 2, added 2 to get to my vertices. So these are my 2 vertices. I didn't put them on the right coordinate plane, but I just wanted to do this little sketch so I could figure out what the vertices are. So these are my 2 vertices, negative 1, negative 2, and 3, negative 2. Okay, if I wanted to find the focal points, they didn't ask us this, but I could, because I know in this one that in the hyperbola that c squared equals a squared plus b squared. And so I know that c squared equals 4 plus 9 equals 13. So c equals the square root of 13. Okay, so I kind of went through that fast. But if I wanted to figure out where exactly this doesn't come out to be a nice number, but I could figure out that the the focus point, one focus point is whatever 1 plus the square root of 13 is at negative 2. And the other focal point is 1 minus the square root of 13 along that negative 2 also. That's one focus point, and that's the other focus point. Okay, so I hope that helps you a little bit in figuring out hyperbolas, and that's it for the lesson today. So fill out the form below, and we'll see you in class tomorrow.